Assalamualaikum and welcome back. Today we are going to have lecture number 15. In this lecture we are going to do some more numerical problems on convolutional integral. You understand, to find the convolution using the graphical method, whether the convolution sum or convolution integral, we have to plot both the signal, that is the input signal and the response signal, and then we reflect and shift one of the signal, right? So it's a good practice that you use a separate piece of paper to plot the signal that you want to reflect and shift, so that you can move it very easily, slide it very easily on another one to find the different intervals and the values of the output. So here we are given two signal. One is the input signal, that is exponential signal, and it is it exists. It is e power 2t into u of minus t. So you understand, if you multiply a signal with the step function, it means the signal has non-zero values for certain range of the t values depending upon the step function. Like in this case, the step function is u of minus t, so that means u of minus t will exist from minus infinity up to 0. So that means this signal will exist from minus infinity up to 0. The response signal is another step function which is shifted 3 units to the right. You understand, this value is 3, so this is plus 3. Plus 3 means that this signal has been shifted 3 units to the right. So you can notice that both the signal, that is the input signal and the response signal, they both exist up to infinity. So let's find the convolutional integral for this problem. So I have plotted the two signal. You can see this is x of t, because x of t is e power 2t u of minus t. So that means, because it's multiplied by u of minus t, so u of minus t is 1 from minus infinity up to 0. So if you multiply the two, that means I will get this for minus infinity up to 0, but for the positive value of the t, because this step function, it will be 0. So that means the resulting signal will be 0 for positive values of the t. Similarly, this is step function 3 unit shifted, so I plotted this one. So the next step is that we replace t by tau. So better is that you make a separate figure for this one, but I'm just doing it here, just replacing t by tau. So I get x of tau, and x of tau will be equal to e power 2 tau, right, into u of minus tau. Okay, the next step is that we reflect one of the signals. So I just reflect the response signal. So something I get is, so I hope you understand that by looking into the mirror, so you can see that this signal will exist from minus infinity up to minus 3. This is 0, and this is tau, and this is your h of minus tau. So after shifting, after reflection, we'll add some negative value of t, right? So it will make the signal shift to the left side, you understand, right? Because the shifting parameter, if the shifting parameter t0 is positive, signal is shift right, and if the shifting parameter t0 is negative, then the signal is shifted left. You understand? This is your time axis, so this is 0. To the left side it is negative, and to the right side it is positive. So if shift is by some a negative value, then it will shift to the negative side, right? So this is what we obtained. Then the next step is that we multiply the two signals, and after multiplication we take the integration, right? So if you look at this one, we can say that basically this signal is also extended up to infinity, right? So if you look at this one, we have for some negative value of t, so we have this expression, so t minus m1t is negative, the signal is here. So you can observe that this signal also exists from minus infinity up to 0, and this signal now exists from minus infinity up to t minus 3, right? So the interesting thing will be that we observe that they have the non-zero overlap for all values until t minus 3 is greater than 0 or equal to 0. So you see, if we bring the signal here, let me draw it again. So I plotted it here, and for t minus t just less than 0, right? So in this case you can observe, because this signal is non-zero from minus infinity up to 0, whereas this signal is also non-zero from minus infinity up to t minus 3, and we assume that t minus 3 is less than or equal to 0. So in this case, you know that we have non-zero overlap. So because this signal is 1 and this signal is e power 2t, in this case the product of the two will result into e power 2 ta, not 2t, 2 ta, right? So we can write here, I just write here y of t equals to integration, and that's because non-zero from minus infinity, and this non-zero thing continues until t minus 3, right? T minus 3, and the product equals to this signal is 1 and this signal is e power 2 ta, so I can write e power 2 ta d ta, and this is valid for t minus 3 is less than or equal to 0. So for these values of t, this expression is valid. Now by taking integration, we can find that, so taking integration, we'll find e power 2 ta divided by 2, and the value of limits of integration of minus infinity up to t minus 3, right? So by putting the value, we find e power 2 ta. So if I replace this by e power minus 2 into infinity, and minus sorry, this is the lower limit, so the upper limit will be e power minus e power 2, right, and t minus 3. You understand, this is the upper limit, and the lower limit is e power minus 2 omega, right? So e power 2 infinity, right? So e power minus infinity equals to 0. So that means we have 1 by 2 and e power 2t minus 6. Okay, for the second interval, you can easily observe is if I move the signal towards the right, you can observe that the upper limit will now be fixed, and that is 0. So that means from lower limit that will be minus infinity up to upper limit that will be plus I mean 0. Okay, so the second interval values for the second interval can be written as y of t equals to integration, and because you see this signal is 0 beyond 0. Okay, so this exists from minus infinity up to infinity, so that means now the upper limit will be fixed, and that is 0. So the lower limit is already fixed, that is minus infinity, and the upper limit is fixed, that is 0. And we have the product is because this one is 1, so we have this is equal to e power 2 tau, right, and d tau. And what is the range of t for this? So the range is when t minus 3 is equal to or greater than 0, because at 0 it will be this one, right? So for greater than 0 this is fixed. So like you understand, we are moving the signal to the right. So when we are moving the signal to the right, this is your t minus 3. Okay, so when t minus 3 is greater than 0, that means we are in this region. So if this signal is here, but it is extending up to minus infinity, so that means the non-zero overlap will be fixed, and that is from minus infinity up to 0. So what is the integration of e power 2 tau? So again it will be something like 1 by 2 and e power 2 tau, right? And the limit of integration is minus infinity up to 0. So that means you have 1 by 2, upper limit is 0, so e power 0 equals to 1, and the lower limit is minus infinity, so e power minus infinity equals to 0. So that means you get something like 1 by 2. Okay, so that means for the right side we have a constant value of y of t, that is 1 by 2, and that's for sure because there is no this signal is non-zero in this region also, but the upper signal is fixed at 0. So that means we have the constant value of 1 by 2. So because again we have two infinite signals, one is the response signal that is also infinite, and the input signal is also infinite. So in this case here we find that we have only two intervals, right? The first interval is when t minus 2, which is the lower terminal value of this signal. Terminal means that beyond this point this signal is 0, right? So if t minus 3 is equal to or less than 0, so we have one interval, and if t minus 3 is equal to or greater than 0, we have another interval of right. So for the first interval, you can see if t minus 3 is, for example, here, then the non-zero overlap is from minus infinity up to this point. If it is here, then we say the non-zero overlap is from minus infinity up to t minus 3. But t minus 3 has to be less than or equal to 0, because when it is greater than or equal to 0, in that case this signal coincides here, and because the input signal does not exist beyond 0, I mean towards positive side, so that means for the first case we have the variable expression, right? You understand the if you look at the expression we got for the output, you can easily observe that here this value depends on t, right? But for the second interval where t minus 3 is greater than 0, in that case, because both signal from minus infinity to 0 exist, so it has constant value, right? But when you move the signal from towards positive side of the time, this signal is non-zero, but this signal is already 0, right? So that means the maximum or the upper limit for this case will be 0, right? So that means we get a constant value of 1 by 2 for the interval when t is equal to or greater than 0, t minus 3 is equal to or greater than 0, and we have the variable expression when t minus 3 is less than or equal to 0. Let's consider another example where x of t is given as 1 for the t equals to 0 to 1, and x of t is given in terms of h of t is given in terms of x of t, where the independent variable is scaled by a factor of 1 by alpha. Because alpha is less than 1, that means the 1 by alpha will be greater than 1. So that means h of t will be the compressed form of the x of t by a factor of alpha. So if I plot the two signals, I can write, this is for example x of t, this is 1, the amplitude is also 1, so this is x of t, and h of t is compressed by a factor of alpha, so let this be alpha, so this is t, okay, and this is h of t. This is 0 and this is 1 and this is alpha, okay. So you understand why this is stretched, compressed, right? Because the scaling factor is less than alpha is less than 1, and it is basically 1 by alpha times scaling, so that means this will result, alpha is less than 1, so 1 by alpha will be greater than 1, so that means the resulting signal will be compressed. So as you understand, we can reflect and shift any signal. So we reflect and shift the response signal, okay. So the resulting reflected and shifted version, okay. The second step, you understand that this is t, so you replace the t by tau, so this will be also x of tau, and this will be tau, and this will be h of tau. So I reflect and shift the response signal, so if I reflect it, it will be something like this. Now this is minus alpha, this is time, and this is h of minus tau, okay. And the next step is the shifting, so we shift the signal to the left side, so the resulting signal will be something like this. So originally this was 0, now this is shifted by the factor of t, so it will be something like this, and this is t, and this will be t minus alpha, okay. So then we multiply and integrate, so because at this side the input signal will be 0, so the product of 2 will result into 0, so that means y of t will be 0 for t is, because you can see that t is, this is 0, so t is less than 0, t is negative, so the y of t will be 0. Okay, I can write y of t equals to 0, right? And this remains 0 until, because you keep shifting the signal towards this side. So once t equals to 0, at that point the response is non-zero, which is this one, and the input signal is non-zero, which is this one. So that means we have non-zero overlap. So that means when y of t equals to 0, when t is less than 0. Okay, the second interval will be y of t equals to the product of the two will result into, because both the signal, this one has one amplitude equal to 1, this one also has amplitude equal to 1, so that means the product will result into 1, and that's d of tau. And the values for integration are like, if you move this side, then you understand when something like this, let me plot here again. For example, we have something like okay, so if you move this signal right towards right, so the point where we have non-zero overlap is tau equals to 0. Okay, so when you move it, that means your lower limit will be 0 and your upper limit will be t, and this continues until t minus alpha crosses 0, right? So that means when t minus alpha crosses 0, so at that point we have, if I write here, t minus alpha is less than 0, so that means when t is less than or equal to alpha, so that means your interval will be 0 is right, t is less than or equal to alpha, because the moment this point, which is t minus alpha, becomes greater than 0, so that means at that point the input signal, this one will have a non-zero value, but this signal will have 0 value. So that means this representation is valid for this range. Okay, so when I integrate it, I'll get y of t equals to, integration of 1 is tau, and if I replace the limit, I will get t. So that means you have the second interval value equals to t, and this interval is valid when t is equal to or greater than 0 and less than or equal to alpha. Okay, so the next interval will be when t minus alpha is greater than 0. So you can see that at that point we have the full overlap, because this signal fully overlaps with right, this signal is fully overlapped with this one, right? So the second interval will have values y of t. You can do this by plotting this signal on your paper, and you tear out a small piece of paper and you plot this signal there, right? And you reflect it, so you get this signal, right? So when you shift this signal to the right, you can observe this very easily. The important thing is that you make this signal on a separate piece of paper and you slide or shift this signal. Okay, so we get the lower limit for this will be t minus alpha, and the upper limit for this will be t. Okay, and the product of the two will result into 1, and this representation is valid when t is equal to or greater than alpha, And what will be the upper bound or upper limit for this one? It will be, because when you keep moving this one, once t passes beyond this one, at that point you can observe that this signal will become 0, right? So that means the maximum value t can have is 1. So this is 1. Okay, so the next interval will be, the point where t is greater than 1. Okay, and when t is greater than 1, you see this point will cross this point. Okay, so when this crosses, then you can easily observe that beyond this point this signal is 0. So that means the upper limit will be 1. Okay, and the lower limit will be variable, which is this one. Okay, the upper limit will no longer be t as in the case here. Why? Because when t crosses this one, although the response signal is non-zero, but this signal is 0 beyond 1. Okay, so we can write that y of t equals to, because the product of the two will result into 1, so we take the limit of integration. So limit of integration, because lower limit will be t minus alpha, whereas you can easily observe that the upper limit for this case will be 1, so we can write 1 here, and d of tau, and what is the range of t for this? So for sure t should be greater than 1, right? T is greater than 1, greater than or equal to 1, and it will be, this is valid until where t minus alpha crosses 1, right? So that means this is valid when t minus alpha is less than, right? That is valid when t minus alpha is less than or equal to 1. Why? Because t minus alpha is this point, right? And 1 is this point, right? So when t minus alpha crosses 1, at that this signal is non-zero, but this signal is 0. So that means the resulting convolution will result into will have 0 values. Okay, so what does it mean? That means t is less than or equal to 1 plus alpha. Okay, so this is the range of t, so it will be 1 plus alpha. Okay, and the moment the signal moves away, that means t minus alpha is greater than 1, so the product will result into 0. Okay, so these are the different intervals we get. That is interval 1, where output is 0 when t is less than 0. For the second interval, you can see we will have the partial overlap, and the partial overlap starts with t equals to 0, right? And when you keep moving, it will, the moment it crosses this edge, right, the left edge of this signal passes 0. So that means t minus alpha should be less than 0, or t should be equal to alpha. That's the maximum for this interval. Okay, so let's solve this. Okay, so if we solve this, that's quite straightforward. We have y of t equals to integration of 1 will be tau, and limits of integration are t minus alpha up to t, right? So if you put here, you will get upper limit minus lower limit, so t minus alpha, so this becomes t and minus becomes plus, so you get for this interval is alpha. Okay, so that means y of t here, it will be equal to alpha. Okay, and the range of values of t, this is the range of values of t for this interval. Okay, for the next interval, upper limit is fixed, so you just take the integration of 1, so integration of 1 will be equal to tau, right? So that means y of t equals to tau, and the limits of integration are t minus alpha up to 1. Okay, so when you put this value, you get 1 minus t, right, plus alpha. So this is which interval? Okay, so after that, after this interval, you notice that this signal moves, or this passes this signal, so y of t will be 0 for y of t, right, equals to 0 for t is equal to or greater than how much? So that's straightforward, that this point is t minus alpha, so once it's greater than 1, so when t minus alpha is greater than 1, that means when t is greater than alpha plus 1, when t is greater than alpha plus 1, so for that case we have 0 non-zero overlap, so the convolution will have 0 value. So these are some of the numerical problems that I have done for you, and there are some problems on the next slide. So these are some of the example. I think I have done them, but I also want you to go, maybe these I have done, so you can go for these other problems, right? So here you are given a response signal, this is equal to this signal. I hope that's quite straightforward, right? Because just you have the exponential signal, this one, and another exponential signal, but you understand they have been multiplied by the step function, right? So you understand the step function has value equal to 1 only when its argument is equal to or greater than 0. So you understand this is the argument of the step function here. So you first I want you to plot them so that you have clear understanding what is happening here, right? So you understand when this signal will be 1, whether for positive value this signal will be 1, for negative, and how much shift is here. Similarly, this signal is also shifted, right? So this is also step. I think that's quite straightforward, right? This one, because you have a step function and that is shifted 5 units, which direction, positive or negative. But because you can see that 5 is positive, right? When 5 is positive, that means this signal has been shifted to the right, or we can also call that we can also say that this is basically delayed by 5 units. Okay, so you have the signal, and you have given the reflected and shifted version of this, and what you need to find is the values of A and B. So hope that's straightforward and you can do it. Okay, another problem you are given here is that you have exponentially decaying or growing signal. Do you think it's a finite or infinite signal? E power minus 3t. Okay, so again, if you look at this one, this signal is basically multiplied by the step function, and that is u of t minus u of t minus 2. So that means it's a very the signal is of very brief duration. Why? Because the step signal is 1 for a very brief duration, that is from 0 up to 2. The step function is 1. So when the step function is 1, you multiply this signal, so this signal will also be 1 for not 1, but it will have some value equal to this one for a t equals to 0 up to 2. Beyond 2, this signal will be 0, so multiplying this with this will result into 0. So that means you have a very brief duration signal, this one input signal, and this signal is infinite, right? You understand, e of minus t multiplied by u of t. So when it's multiplied by u of t, that means this t cannot have the negative value, because if t has negative value, in that case u of t will be 0, and you multiply this with this one, so that means your response will be 0. So that's also a pretty straightforward thing, and I want you to go through it by yourself and do it right. So this is problem. Okay, again we have another problem. Here you are given x of t equals to u of t minus 3 minus u of t minus 5. So again it's a short duration input signal, and you have the infinite response signal, and what you need to know is to find the what you have to find is the value of the output signal. Okay, so I hope you can do it quite easily. Sure, right? Okay, the next signal is the EFT. This is from Oppenheim, right? So you understand we are doing the textbooks are the Oppenheim, right? Signals and Systems by Alan V. Oppenheim, Alan S. Wilsky with S. Hamid Nawab, right? So this is your textbook. So I hope all of you have it, and most of the problems and examples we do are from this book, right? This is the second edition. Another book is your Signals and System, and that's also second edition, and this is by Simon Hacking and Barry Van Veen, right? Although you're in the course outline, details have been provided to you, and the names of the books and their edition is also provided there. Okay, so I hope that's straightforward, you can do it. So I think that's all for today. That's the next topic is the properties of Lti system, which we will start from the next lecture, and after this lecture that's all about the convolution sum and convolution integral. So you have been provided the numerical problems so that you can further improve your concepts, and the important thing is that you should try by yourself. It's a very easy thing, whether it's a convolution integral or it's a convolution sum. You just plot the two signal. You have been provided so many examples for solving these problems using graphical methods. So that's quite straightforward method, that you plot the two signal and then you replace the independent variable. In case of discrete time, we replace the independent variable by the k, and in case of continuous time signal, we replace the independent variable by tau. Okay, then up to your convenience, whatever you think is convenient for you, you reflect one of the signal, right? Whether it's the response signal or it is the input signal, you reflect it, and then you add some negative value, right? So in case of discrete time signals, we say we add a big negative value n, which makes the signal shift to the negative side, right? Because most of the signals, they are on positive side. So we add it so that the resulting discrete time signals shifts to the leftmost, and then you multiply the corresponding values, then you sum them, and then you shift the signal, right? Like we use the word SMS. That means shift, multiply, and sum. This is for the discrete time case, okay? And you keep doing this. And for the second case, that is for the continuous time case, we do the same thing, but instead of summation, we do the integration, right? So you shift the signal, then you multiply the corresponding values, and then you take the integration of result, okay? And then you move again, shift again, and you repeat this process until you go in the reach in the area where the other signal is 0. So by that you get the complete values for the output signal, right? Remember that convolution sum or convolution integral, that you understand that this is for discrete time and continuous time systems, right? So they both are valid only when the systems are linear and time invariant. If the system is non-linear or if the system is time varying, in that case we cannot use the convolution sum or the convolution integral, depending upon, you understand, if we use the convolution sum for the continuous time case, whereas we use the convolution integral convolution sum for the discrete time case and convolution integral for the continuous time case. So that's all for today. In the next lecture we'll start the properties of LTI systems. See you.